Okay, after doing the connections, okay, now we will see the connections also. See, from plus to ammeter plus, power supply plus to ammeter plus. So power supply plus has gone to ammeter plus. This is ammeter. This is configured as voltmeter. So from here it has gone to ammeter plus. Then ammeter minus to resistance R1. Ammeter minus to resistance R1. ಇಲ್ಲಿಗೆ ಬಂದಿದೆ. One side of resistance R1. Okay. Don't see voltmeter now. Voltmeter you can see at the end. Okay. Next, resistance R1's other end to one end of R2. So resistance R1's other end to one end of R2. Yes, so we have connected till here. Next, R2's other end to minus of power supply. That is R2's other end to minus of power supply. Then connect voltmeter across R1 such that plus of voltmeter should go to the first terminal of R1, that is where the ammeter negative has gone. So this is voltmeter and this is R1. R1's first terminal is this one. So here this should go to voltmeter positive. This is the voltmeter has gone to voltmeter positive. And the other end of R1 should go to minus of voltmeter. Other end of R1 should go to minus of voltmeter. Black lead is minus, so that should connect. That should go to the minus of voltmeter. You have to do a well practice of this. 3 times you have to do these connections. We will try to make the soldering ಮಾಡಿಟ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ. Okay, after doing this, switch on the power supply. Switch on here and here. Okay, before that configure this as voltmeter. This as ammeter. You will keep this in 200 milliampere. You will keep this in 20 volt. You will give here 30 volts. But here the voltage will be divided across R1 and R2. So here you will get a maximum of around 15 volts only. So you can keep this at 20 volts. But if you have doubt, you can keep this for safer side 200 volts. Then there is no problem for voltmeter at all. No risk at all. Let us switch on, and then you should first, while starting, you should keep the voltage knobs at 0 and current knob at some higher value. Current knob should not be at 0. We will see what happens if you keep it 0. See, suppose if I keep it at 0, if I switch on, you see, now this is giving red indication here, you can see. Okay, you can see it's red because we have kept the current setting as 0. It says I am loaded. That is why it is giving red signal here. You keep this higher value, red has gone. So you should keep this at a higher value for accurate readings. Now you give here some voltage. Say you have given here 6 volts. Out of 6 volts, now this is showing 3 volt reading. So you have given here 6 volts. Out of 6 volts, 3 volts is here and 3 volts is here. Okay. So we can take reading now. See here 3.1 volt. Okay, I will write here 3.1. See, I will, for getting better voltage, I will keep this in 20 volts now. So 3.06. I will make it 3.1. Okay. 3.1. Okay, 3.0. Okay, 3.0. What is current? 5.7 milliampere. This is in milli. So current is 5.7 milliampere. So 5.7 into 10 to the power of minus 3. ampere. Okay. Next, increase this, say some 5 volt. Okay, 5.2, 5.19 means you can write 5.2. Okay, 5.18, same you can write 5.18 volt. Current is 9.8 or 9.9, 9.8 into 10 to the power of minus 3 ampere. And here make this something around say 8.1 ampere volt. This is volt. Ampere is 15.3 in 10 to the power of minus 3 ampere. Next you increase this, say something, say 10. See, when this is 10, this will be around 20, double. 10.64. 10.64. This is 20.3. Bye bye. I have put minus 3, 10 to the power of minus 3 because this is in milliampere. So to convert milliamps into ampere, you have to multiply by 10 to the power of minus 3. Last reading, we can have this as something around 12 point, okay, 14 point, okay, 13.97. 13.97, that is 26.6. Then bring all the knobs to 0. Now you see, now that the reading has come almost zero current, and after that switch off the power supply. You can check whether this has become hot. A little bit hot this has become. You can see this is cold, this is a little bit hot. Okay, but we have not given a high current, that is why these resistances are safe. Otherwise, if you have taken 5 watt resistance or small size resistance, this would have got overheated and burnt. Now you have to do the calculations and then take average of do the calculations. So okay, we will do the calculations. Take calculator. 3 V by I. Okay, 3 by 5.7. 3 by 5.7. 3 by 5.7 equal to 0.526 into 10 to the power of minus 3. See, R is equal to case, you can write here case 1. Okay, R is equal to V by I is equal to 3.0 by 5.7 into 10 to the power of minus 3 equal to 3 by 5.7. Now this goes to top, it will become 10 to the power of 3. Okay, denominator in the numerator ಗೆ ಹೋಗುವಾಗ 10 to the power of minus 3 ಹೋಗಿ 10 to the power of plus 3 ಆಗುತ್ತೆ. So this is ಎಷ್ಟು 0.526 ಎಷ್ಟು ಹೇಳಿ 0.526 31 ಸಾಕು ಇಂಟು 10 to the power of 3 equal to 1000 ಅಲ್ವಾ 1 2 3. So 526.31 ohms. You can write here 526.31 ohm. Take second case, 5.18 by 9.8. ಎಷ್ಟು 5.85 ಪಾಯಿಂಟ್ 5.85 ಮತ್ತೆ 5 ಆದಮೇಲೆ 7 ಸೇಮ್ ಬರೀರಿ 5.2857. ಆ 5.28 ಆದಮೇಲೆ ಪಾಯಿಂಟ್ ಹಾಕಿ ಒಂದು ಕರೆಕ್ಟಾಗಿ ಮಾಡಿ, ಬೇಕಿದ್ರೆ ಎಲ್ಲವೂ ಮಾಡಿ ಮತ್ತೆ ಅರ್ಥ ಆಯ್ತಲ್ಲ ಹೇಳಿದ್ದು ಅಷ್ಟೇ. 3 ಕಡೆ ಡೆಸಿಮಲ್ ಆಚೆ ಕಡೆ ಹಾಕಿದ್ರೆ ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಮಾಡಿ 8.1 by 15.3.
0.2
5
2
2 ಬರಲ್ಲ
ಸರ್ 5 2
5 2
ಹಾಂ ಸರ್
5 2
9 4 1
9 4
ಹಾಂ
ಡಬಲ್
1 1
ಹಾಂ ಓಕೆ 5 ಬಾಕಿ ಬಿಟ್ಟುಬಿಡಿ ಟೇಕ್ 5 ಡಿಜಿಟ್ಸ್ ಪುಟ್ ಪಾಯಿಂಟ್ ಹಿಯರ್ ನೆಕ್ಸ್ಟ್ 10.64 by 20.3
0.52 41 37
Okay, next 13.97 by 26.6
0.52 51 87
87 ಅಲ್ಲ
ಹಾಂ.
ಸೊ 87 ಬಂದರೆ ಇಲ್ಲಿ 9 ಮಾಡಬೇಕು
ಆ ಥರ ಇದೆ.
ಹಾಂ ತೊಂದರೆ ಇಲ್ಲ ಸಾಕು. ನಾವು ಟೇಕ್ ಆ್ಯಾವರೇಜ್ ವ್ಯಾಲ್ಯೂ. ಐ ಶುಡ್ ಹ್ಯಾವ್ ರಿಟರ್ನ್ ಹಿಯರ್ ಎ ಲಿಟಲ್ ಬಿಟ್ ಡೌನ್. ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಆ್ಯಾವರೇಜ್ ಆಫ್ ದೀಸ್. ಓಕೆ, ಆ್ಯಡ್ ಆಲ್ ದೀಸ್ ಆ್ಯಂಡ್ ಟೇಕ್ ಡಿವೈಡ್ ಬೈ 5. ವಿಲ್ ಗೆಟ್ ಆ್ಯಾವರೇಜ್ ವ್ಯಾಲ್ಯೂ. ಬಟ್ ನಾವು ಯು ಹ್ಯಾವ್ ಕ್ಲಾಸ್ ನೋ ಕ್ಲಾಸ್ ಇದೆಯಲ್ಲ ಈಗ,
ಹಾಂ ಸರ್.
ಯು ಕ್ಯಾನ್ ಕಮ್ ಆಫ್ಟರ್ ದಿ ಕ್ಲಾಸ್.